hot spark at the right time. There's nothing more important for engine performance, fuel economy, and emission control. The hot spark at the right time is produced by the ignition system. And starting with the 1978 model year, AMC cars and Jeep vehicles are equipped with a new electronic ignition system called SSI. This training release will cover what you need to know about working with the SSI. SSI, or solid-state ignition, is an easy-to-understand, easy-to-work-with electronic system. In this training release, you should learn how to identify the components of the SSI system. This will help you locate these components under the hood. You should also learn about the operation of the SSI system. This will help you diagnose causes of ignition problems. You should become familiar with the SSI testing procedures. This will help you locate malfunctions. And you should understand the service needed to correct malfunctions. First, let's look at the components for the SSI system. The components of the SSI system have familiar names. There's an electronic control unit, a coil, a resistance wire, a distributor cap, a rotor, ignition wires, and spark plugs. These components look much the same as those you've worked with on other ignition systems for AMC cars and Jeep vehicles. The Electronic Control Unit, or ECU, is especially designed for the SSI system. It is easily recognized by an unpainted metal case and two unique weatherproof harness connectors. The coil is also especially designed for the SSI system. This coil can handle a high primary current. It has a special condenser to limit radio interference. It also has a unique slip-on connector for the primary wire connections. A resistance wire is used in the battery feed circuit to the SSI system. This wire is connected to the starter solenoid on AMC cars and directly to the coil on Jeep vehicles. The SSI distributor has a trigger wheel and a sensor. The centrifugal advance mechanism is located under the plate beneath the trigger wheel. The vacuum advance mechanism has a metal housing mounted on the distributor body. The other SSI components include a blue distributor cap. This cap is held in place with two screws rather than clips. The rotor is black plastic with a brass tip. The ignition wires and the spark plugs are basically unchanged from those used on previous AMC and Jeep ignition systems. All of the SSI components can be easily located under the hood. Your film reference booklet gives the component locations for the different AMC and Jeep engines. The booklet also gives the SSI wiring diagrams. It's easy to understand the operation of the SSI system. Here's a breaker point ignition system with its well-known points, condenser, cam, and rubbing block, parts requiring frequent service. As you know, the breaker points serve as a low-voltage switch. They switch the primary current off and on, breaking and making the coil ground circuit. The points are opened and closed by the cam and rubbing block. These parts control the spark timing and dwell. For a quick review, when the points are closed, current can flow through the coil primary to ground. This builds up a magnetic field in the coil. When the cam rotates and opens the points, the current is switched off. This collapses the magnetic field, and a high voltage current flows from the coil's secondary winding to fire a spark plug. The breaker point ignition system has been the standard for many years, but it has several disadvantages. Burned points require replacement. A worn cam and rubbing block changes dwell, or the time that current can flow through the coil. It also changes spark timing. To eliminate the problem of point wear and replacement, the SSI system uses a transistor to switch the primary current off and on. This transistor is in the electronic control unit. Like a relay, this transistor requires a small signal voltage to switch it on. When the transistor is switched on, The ignition primary current can flow through the coil primary winding and the transistor to ground at the distributor. When the small signal voltage is shut off, the transistor shuts off, like a relay. The primary current cannot flow through the coil primary winding to ground. As in the breaker point ignition, this collapses the coil's magnetic field and induces a high secondary voltage. To eliminate the problems with cam and rubbing block wear, the SSI system uses a trigger wheel and sensor. These parts have no physical contact and do not wear. They send a voltage pulse to the ECU. This pulse is decoded by ECU electronics, which switch off the transistor in the ground circuit of the coil primary. Initial timing is controlled by the relation of the trigger wheel teeth to the sensor. Timing is changed only by the distributor advance mechanisms. Dwell is controlled by the electronic circuits in the control module. It is not adjustable and is automatically changed as needed to meet ignition requirements at various engine speeds. In the SSI, dwell does not affect spark timing. The trigger wheel is gear-shaped with the same number of teeth as cylinders in the engine. It's mounted on the distributor shaft and held in place with a small roll pin. It rotates with the distributor shaft. The sensor is mounted on the outer edge of the distributor base plate. It contains a permanent magnet which sets up a magnetic field around a small pickup coil. The sensor is connected to the SSI electronic control unit by a harness with color-coded wiring. When the harness connector is hooked to the distributor connector, the orange and violet wires complete the sensor circuit to the ECU. The black wire completes the coil ground circuit through the ECU at the distributor body. Here's what happens when the engine is running. As a trigger wheel tooth nears the sensor's magnet, the magnetic field shifts toward the trigger wheel. The metal in the tooth does this by reducing the magnetic resistance or reluctance around the sensor pickup coil. When a trigger wheel tooth is aligned with the sensor's magnet, the magnetic field has shifted to its maximum. And when the trigger wheel tooth passes the sensor's magnet, the magnetic field moves back to its normal position. The moving magnetic field generates small but measurable alternating voltage pulses in the sensor coil. This sensor signal tells the transistor in the ECU when to switch the coil primary current off. The electronic control unit, or ECU, decodes these sensor signals and switches the coil primary current off. This starts an electronic timer in the ECU, which leaves the primary circuit broken just long enough for the spark to occur. It then closes the circuit and switches the coil primary current on once again. As such, dwell is automatically adjusted. Also, another special circuit prevents false signals from triggering this switching action. The ECU is hooked into the system with a pair of weatherproof connectors. The 4-wire connector is used for the sensor signal circuit as well as for the coil ground circuit. The 2-wire connector is used for the battery feed circuit to energize the ECU. In testing the SSI system, you will use many of the same procedures you've always used for ignition diagnosis. There are 3 basic groups of ignition tests. These are preliminary checks, secondary circuit checks, and primary circuit checks. The preliminary checks involve a visual inspection of the system, spark intensity tests, and spark timing tests. For these, you can use the same testing and correction procedures that you have used on our previous ignition systems. The visual inspection is an important first step. Check for loose, corroded, or damaged connections. Check for damaged components, such as a cracked coil or distributor cap, and cracked or frayed ignition wires. Also, check to make sure the battery is in good condition. If any problems are found, make the necessary corrections. When the engine cranks but won't start, a spark intensity test is a good quick check of ignition performance. Interpret the test results as you have always done. These results will give you a good start toward diagnosing the cause of failure to start. There's one special caution to remember when performing a spark intensity test on the SSI system. Removing certain spark plug wires may cause damage to the sensor. These wires should not be removed. Numbers 3 and 5 on 6-cylinder engines and numbers 3, 4, and 8 on the V8s. The sensor is mounted below these terminals in the distributor cap. If these wires are open-circuited, the ignition voltage may jump from the rotor to the sensor instead of to the cap terminal. When the engine backfires, runs rough, pings, or has sluggish acceleration, a spark timing test should be performed. Check and set initial timing to specifications. Check the performance of the centrifugal advance and vacuum advance. Make any necessary corrections. When performing the spark intensity test, if you get a weak spark at the spark plug but a good spark at the coil, check the ignition secondary circuit. The secondary circuit checks can help you diagnose problems with the spark plugs, ignition wires, distributor cap and rotor, and coil. You will use your normal testing and service procedures. Again, for your easy reference, these procedures are outlined in your film reference booklet. Spark plugs should be inspected and cleaned or replaced if necessary. The condition of the spark plug tip may give you an important clue to engine and fuel system problems. Ignition wires can be checked with an ohmmeter for high resistance or lack of continuity. Also, check for improper routing that might cause cross-firing. Replace any damaged wires. The distributor cap should be checked for corroded or burned terminals, cracks, or carbon tracking. The rotor should be checked for burned contacts. A small amount of silicone grease is on the rotor blade to reduce radio interference. Replace a damaged cap or rotor. The coil should be checked with an ohmmeter or a coil tester. Also, visually inspect the coil for damage. Replace an out-of-spec or damaged coil. And, as always, the secondary circuit performance should be checked with a scope. If the spark is weak and the secondary circuit checks out okay, check the ignition primary circuit. The primary circuit checks can help you diagnose problems with the trigger wheel and sensor in the distributor, the electronic control unit, the coil, and the wiring harness. These checks involve simple tests with an accurate voltmeter, ohmmeter, and ammeter. You will check the battery feed to the ECU, the coil ground circuit, the sensor signal circuit, and the battery feed to the coil. Once the problem is found, there is no need for further checking. In many of the tests, you'll be checking for specified voltage or resistance in various parts of the SSI primary circuit. You'll need to become familiar with the coding used on the connectors for the SSI components and the system wiring harness. Your film reference booklet has a detailed explanation of these connectors. Use the booklet as a guide and feel free to turn off the projector if you want to trace the wiring diagram during the following tests. Your first SSI tests are on the battery feed to the ECU. Disconnect the 2-wire connector at the ECU. One half of this connector is the battery feed for special circuitry that minimizes fault signals from the starter. To check this feed, connect a jumper wire between the E1 terminal on the ECU connector and the F1 terminal on the harness connector, and connect a voltmeter between F1 and ground. The voltmeter should be set on a scale for 15 to 25 volts. With the key in start, the voltmeter should read battery voltage. With the key in the on position, the voltmeter should read 0 voltage. If you do not get correct readings, check the circuit wires and connections from the battery. To check the feed wire for this special circuitry, remove the jumper wire and connect an ohmmeter from the F1 terminal on the harness connector to the S terminal of the ignition switch connector. You should get a 0 resistance reading. If you do not, there's a high resistance problem in the wire, the SSI connectors, or the dash connector. The other half of the two-wire connector is the battery feed for normal operation. To test this, connect a jumper wire between the F2 and E2 terminals, and connect the voltmeter between F2 and ground. The voltmeter should read battery voltage with the key in either the start or on position. If the voltage readings are incorrect, remove the jumper wire and connect the ohmmeter between the F2 terminal and the I1 terminal of the ignition switch connector. If the connectors and wire have no problems, you will get a 0 resistance reading. To check the coil ground circuit, you will have to reconnect the ECU 2-wire connector and disconnect the ECU 4-wire connector. Connect an ohmmeter from the D1 terminal of the harness connector to the distributor body. You should get a 0 resistance reading. If the ohmmeter shows excessive resistance, check for problems at the ground screw in the distributor and at the B1 terminal of the distributor connector. To check the ground circuit inside the ECU, connect an ammeter from the C1 terminal of the ECU connector to ground. With key on, you should read about 1 amp. In start, about 2 amps. If you do not get these readings, the ECU may be bad and require replacement. To check the ground at the coil, reconnect the 4-wire connector and connect a voltmeter from the coil negative terminal to ground. The voltmeter should be set on a scale for 2 to 3 volts. With the key on, the reading should be less than 1 volt. Next, check the ECU's ability to switch the coil ground circuit. Change the voltmeter setting to a scale for 15 to 25 volts. With the coil wire removed from the cap and grounded, the voltmeter should pulsate during engine cranking. With the coil wire reinstalled and the engine running, you will get about 7 volts at idle and about 10 volts at 2000 RPM. To check the sensor signal circuit, you'll have to disconnect the ECU 4-wire connector again and connect a voltmeter between the D2 and D3 terminals of the harness connector. The meter should be set on a scale for 2 or 3 volts. When the engine is cranked, the meter needle should fluctuate. If it does not, check the distributor components. Check for a broken trigger wheel, damaged sensor, or locked up distributor shaft. Next, turn the engine off and check the resistance of the sensor. The ohmmeter should be set on the R times 100 scale and its leads connected to the D2 and D3 terminals. The ohmmeter reading should be between 400 and 800 ohms. If it is not, the sensor is bad and should be replaced. Your last check is a check of the battery feed to the coil. Reconnect the ECU 4-wire connector and connect a voltmeter from the coil positive terminal to ground. During starting, you should get between 9.6 and 12 volts. If not, check for resistance at the I terminal of the solenoid, the neutral safety switch, connectors, and related wires. With the key on and the engine off, you should get about 6 volts. If not, the resistance wire or condenser at the coil may be bad. With the key on and the engine on, you should get a reading of about 11.5 volts at 2000 RPM. By following this step-by-step testing approach, you should have no trouble diagnosing causes of SSI malfunctions, and the service is easy too. There are no special procedures for removing and installing the SSI distributor. You will use your normal procedures with the same steps for setting initial timing. The trigger wheel and sensor cannot be serviced. If they are defective, they must be replaced. The trigger wheel is removed using a small gear puller. The sensor is removed by unscrewing the ground from the harness tab and removing a retainer ring and 2 washers from the pivot pin. The coil and ECU also cannot be serviced. If defective, they too must be replaced. The coil is held in place with 2 screws. The ECU is held in place with 3 screws. When replacing the ECU, or when testing its harness connections, unplug the connectors by hand. Do not pry on them with a tool, or the connector locking tabs may break off or fail to lock when the connections are remade. If this should happen, simply tie or tape the connectors together to keep them in an operating mode. All of these service procedures are detailed in your film reference booklet, as are the other topics covered in this film. By applying what you have learned here and using the booklet as a guide, you should quickly develop the diagnosis and repair skills needed for working with the SSI.